Plastics are ubiquitous. They're found everywhere, and we all have interacted with them at some point in our life. Unfortunately, some of those plastics is getting into the marine ecosystem, and this is a big problem.
The Curing Microbes on Ocean Plastics project.
My name is Dr. Rachel Simmons. I co-wrote this project with Dr. Anna Burrell, and what we're really hoping to do is demystify science and scientists. Science is performed by regular people, and if it's performed by regular people, you can do it too.
What we're trying to do is use microbial degradation of ocean plastics as an essential learning topic for introductory biology students at National University. So the students get to benefit from all the access to the research infrastructure that we have here at Scripps, and we get to benefit from educational opportunities with those undergraduate students.
This project is an education project for, increasing engagement and success in STEM. But it also has the research part, and we are looking at the microbes attached to the plastic.
And I think that educating students and our public is extremely important in better understanding what's actually going on with plastic trash in our oceans.
What's so engaging is that students get a chance to go out on the pier, something that's unusual outside of the classroom.
The thing that really roped me in was the first field trip out here at SIO.
Myself and Jeff got our scuba gear on, and the students saw us go into the ocean and retrieve some of the samples that are being incubated on the Scripps Pier. And then we took those samples back into the lab, and they were able to see plastic and what it looks like with the microorganisms growing on there.
It brings a true story to the student.
When we put our plastic incubations in, the amount of biomass that accumulates on those plastics in a very short amount of time is really profound. So it's really made me aware of the amount of plastics that's out there and the amount that plastic interacts with all of the life in the ocean, including ocean microbes. A lot of the students that are coming into this program are non-traditional students. They're students that are re-entering college a little bit later in life, may not have had a whole lot of formal science training, or if they did, it was a long time in the past.
It's been like so many years since my last biology class, and even at my last school, so it's kind of a rush stretch.
We like to showcase that there are many different paths for getting here, and with the panel, we want to make this field more inclusive and a viable option for everybody who is interested.
Computer guy, I was like, wait a second, I can love marine biology and be a computer guy too? I was like, yes, this is for me.
This has just been an awesome experience overall.
We are using cutting-edge technologies such as sequencing to understand what are the microbes in that water column and what are the ones that are colonizing the plastics, to better understand how they might be breaking down some of those little pieces. And we hope that the work we're doing could help us understand the many different layers of this issue so that we can find sustainable solutions. And there are many misconceptions about this issue.
You always get the question, well, why the heck can't we go out there and just clean it up? Furthermore, everybody talks about this island of plastic that's out in the Pacific. The highest concentration of plastics that's been yet recorded in the Pacific. It is not an island. It is little tiny shards on the surface of the water. As these plastics come from the land and travel through the ocean, of course there's wind, wave, UV from sunlight action is breaking this plastic down over time. And they end up these really small pieces. Because these pieces of plastic are so small, you really can think about them like you think about smog. We'd love to clean up smog. If there was a way to clean up smog, they would be doing it. We know that there's a problem with plastics in the ocean. That has been proven. Because ideally, environmental policy should be catalyzed by scientific evidence rather than environmental catastrophe.
arms of this project are going to move forward. We plan to disseminate the project to other schools, institutions, and actually we would like to move into high schools, the K-12, to increase engagement and interest in STEM from early on.